Welcome to another episode of Dominic Does DIY. Today we're going to continue with looking at the remote control relay system from the last video. And we're actually going to go through the process on how it is that we can come to make the remote control using an Arduino, a Bluefruit, and a secondary microcontroller. I'll be using the ESP32, which still uses the Arduino platform. But it gives us a little TFT display, so we'll go through a little bit on that section. But for today's episode is just going to be about us making the Bluetooth side of the relay board that we had. So thanks for joining. As always, please click subscribe, share the video, comment down below, and let's get on with this. So as a reminder, just from our last episode, I was showing the relay board on the Arduino and how we can push this button on this microcontroller right here on this ESP32 board with the TFT display. We can push the button, and as you can see, our LEDs over there are changing. So we are able to, via Bluetooth, send commands in order to control those relays on the Arduino board. But today's episode, like I was saying, we're not going to worry about the remote right now, so we'll put that off to the side. And we're just going to focus on the relay board. We're going to focus primarily on, because we've already got this section working. We've already got the relay boards and the LEDs operating. So before we were using this little toggle button, this little switch, to go ahead and toggle the lights back and forth. But now we're going to exchange that for Bluetooth commands, right? And so to do that, we're going to go ahead and be using this Bluefruit UART Bluetooth command little dongle. It's actually pretty useful. It can only be used as a peripheral, so that's where its one limitation is. It can only be a peripheral, whereas our remote, that'll be the central. And so this thing can't do some of the things that other full-fledged Bluetooth things. If you had like a NRF dev kit or something like that to do Bluetooth commands, I could do peripheral and central. It'll have a little bit more flexibility, but this one right here, it's pretty good for just being on the peripheral side. So let's take a look. We'll start always by first looking at the data sheet of the Bluefruit dongle itself, so we can come to understand how it communicates and what its capabilities truly are. So here we have the datasheet for the Bluefruit dongle. It actually uses an NRF module. It just uses the 810, I believe. And so it has a very limited feature set. But what it does do is it has an ability to either send just strict UART. So you can have easy mode where you're just using it as a Bluetooth UART communication device. Or you can use it to actually send commands, and those commands are the AT commands. But let's take a look, dive into that sheet a little bit more and come to understand what it can do. So the first thing we want to look at is what exactly are the technical specs of this little dongle, this Bluetooth dongle. Well, it says we got about 256K flash memory. So this thing communicates via UART at 9600 baud. So the other thing we got to look at is how we're going to communicate with it. So we're going to use these easy AT commands in order to do more than just UART communication back and forth, right? We don't want to do a simple UART, even though this will do it. You can see right here, we have a switch on the board itself. You can choose either UART or command, and that's the difference. So if you're just UART, you're going to be simple transmit receive over UART, and if you are AT commands, it allows us to do a little bit more, run characteristics and things like that. So we're going to do AT commands so that it gets a little more complicated. We can kind of see how Bluetooth operates. So what's the pin out of the board? How are we going to connect it up? Well, we can see right here the mode pin, CTS, transmit, receive, VN, RTS, ground, and DFU. And we're going to need pretty much all of those pins in order to make this thing operate. The only pins we will not need is the mode pin and the DFU pin. If you're going to run a dongle or some other device with UART is to just buy a Mega. That way you have a dedicated hardware UART for that. And then you still can have your UART dedicated for serial output, so you can debug through the serial monitor. So the way we're going to control this Bluefruit is through AT commands. And so we're just going to use the table of contents to kind of go through some AT commands to see what we can do with it. And then we will go through and see how we use these commands in more detail with the firmware. So here we can see some standard AT commands. So the AT is just a general purpose check. So if you send AT command, it will just respond with OK, basically saying communication channels are open. ATI is for some information. ATZ is for a system reset. ATE is for echo on and off. So these are just some standard stuff during the communication process between the two. So we can get some information, or we can tell it what we want it to do, right? Reset, give me your information, or echo commands back. So now we're getting into some Bluetooth actual AT commands. So you can see some generic Bluetooth commands. We got the BLE generic. We can get things like power level, adder type. We can get the address. We can get the peer's address, right? We can get some RSSI. These are all just things that are in the packet, depending on what we want to get. Same with the services. If we want to use basically we want to use the BLE services, those are some commands there. So for this example, actually, these are the two main ones that we're going to want to pay attention to. It's our BLE gap and our BLE GAT. So the gap layer, as you can see, has to deal with prior to connection, roughly, right? Like a kind of like a layman's term part, because you can see this has everything to do with the advertisements. So you can either get connection, disconnect, you can make it connectable, you can delete bonds, get the device name, start, stop advertisement, set advertising data. So this all has to do with the advertising and extrapolating what is being advertised. The GAT layer is basically post connection. So you saw something, you want to connect to it, you connect. After that, you now need to exchange information to do data transfer. So things like services and characteristics are here. And these are the things that I will be using in this example rather than the UART channel, right? So we'll be actually creating services and characteristics. So a service can have can have characteristics, and then the characteristics are the things that can transmit data back and forth. So this is what we will be using. Of all the AT commands, it's a pretty simplified set that we'll see once we get into the coding. So here's our setup. So you can see I'm wiring. I'm using everything. We take a look at this. I'm wiring up everything except sorry about the blue light. I still haven't bought all the equipment I probably need, but so sorry for the blue bright light. But you can see here I'm wiring it up, and the only ones I'm not using is that mode and the DFU pin. Everything else I'm using. So on the Mega, you can see here how I was saying about the multiple hardware UARTs. You can see here I've got TX and RX. That digital output 0 and 1. This is your standard. UART to your serial to talk to the serial monitor. But then you can see for the outputs 14, 15, 16, 17, 18, 19, we have 3 additional hardware UARTs that we can use. And we've also got 20 and 21, which is I2C. We won't be using that. But you can see here I am using serial 1, 18, and 19. Those are the pins that are going back to my Bluefruit control board. So the UART that I'll be using to send the AT commands will be the serial 1 on the Mega. So now that we've got all the connections out of the way, we've read through the datasheet a little bit, now we actually need to get into the code. So there's a lot going on here, but basically I've got a Arduino code, and then I wrote this AT command class. Here's my header file so we can kind of see what's going on here. I've got two constructors, and then I got a series of setters, getters, commands, things like that. And then all I did with all these commands is if we take a look at, let's say, set advertiser name, we can see in the set advertising name in the C++ file that I've got a command, I generate a string, and then I send that string, right? And so the send command is obviously going to send it out the UART. So that's all it's doing. It's creating a string that I send out the UART for the AT command. Then what does the AT command look like? There's the command, the same one that's in this one being used. And then what does this thing do? It gets or sets the device name, which is in the advertising payload for the Bluetooth, so the Bluefruit. So basically when you put your whatever you're using to snoop and see the advertiser, this will be the name that is shown in that device. If we scroll down, how is it that we can use this? So this one had getters and setters, right? I can either set the advertising name or I can get it. The only difference is how it operates. So if I want to get it, I just send this command, that AT plus gap dev name, and then the response will be UART and then OK. And each of these things end with a return and new line command at the end of it. So it would be UART, return new line, OK, return new line. And if I want to set the advertising name, well, then it would be same thing. It would be the command. But in addition to that, I would add equals whatever I wanted it to be. So that's why I have this. So if I want to set the advertiser name, I got to send the advertiser name. And that's all it's doing. It's sending the command. It's storing this command inside this character array. I've given it a max length. And this is the title. As soon as I get this string back, which will resemble this, what do? I send that command. And then what does that command do? Well, it sends it, and then it pretty much waits for this OK right here. Once it gets that OK, I call it good, and I move on to whatever I need to do next. All of these functions basically did exactly that. I looked through the data sheet, and I made getters, setters for everything that I needed in order to perform all these AT commands. So now that I got all those AT commands, right, what is it that we now do, right? So if you remember from the other video where we were just messing with the relay, it's same basic code. So I've got all my relays here. I got my switch. And if you remember in the data sheet, we require RTS and CTS being connected. I've got some stuff here. We'll go over this as we're going through it, but all Bluetooth, basically you have a service, and inside that service, then you add characters to it, or characteristics, and then those characteristics are then what you can use to transfer data back and forth. So my constructor, I create my construction, and I'm basically sending it the serial port. I'm just sending it the address of serial 1. And I'm sending it command mode, which is 1 because I want to be in command mode, not UART mode. And as we go on, we can see there's the relay in it, same one as before. And then my setup. So according to the data sheet, we wanted to keep the serial 9600 baud so we don't lose any characters. And of course, I like talking out to the serial monitor for Arduino at 115.200. It's just my thing. I initialize the relays, and then I proceed to set up the RTS and CTS in order for it to work, right? They need to be set up like this. I don't really mess with them, but I need to set them to this in order to have communication. If you don't set the RTS and CTS, then you will not be able to communicate to the Bluefruit. So you absolutely need that there. And then I go ahead and I initialize my device. So the device initialization, you have to go through a series of steps, right? So let's check that out real quick so we can see what exactly it is that we got to do to initialize this device in order to make it work from the get-go. So here in the function of the init device, some of this I found I just did to clear off any bugs when it starts up. Because remember, this setup's only going to run at boot up, right? So at boot up, I just went ahead and reset the reset the device, disable echo, do a factory reset. I'm not trying to save anything. If you want to keep it, you're not going to want a factory reset if you want to keep it. But for all my stuff, I just started from scratch and let it get going. And I've never had to, because I'm not working on a pairing system. The way I've got it set up is it just the two things know each other. So I actually technically don't have to have a pairing sequence or anything like that. It just automatically pairs because the one knows about the other one, and it's looking and it auto connects. So I don't have to go in and pair. So I don't care about memorizing or remembering it during a reboot. So I just go ahead and factory reset, scratch it all. Wait a little bit, give it time to restart. It does take a second for the module to wake back up. And then I want to get the info. So get device info. This is the ATI command. So that's all it does, the init device. It just basically gives it a factory reset. And then for the same thing, we just want to clear out the system. So after we initialize it, we clear the gap so there's no leftovers of anything. It deletes all the services and characteristics that were stored on the device previously. And then we go ahead and we add a service. So this is my service that I want to add. And then what happens in these ones is when you add a service, it's going to actually return a number to you, which is the index of that service. And you need to know that number in order to recall or request information from that service. So to be able to talk back and forth, you need to be able to reference that service index number. So you have to retain that. I'm going to add a characteristic, and the characteristics gets added by the service. So on these things, you don't want to be, oh, here's my service, here's my service, here's my service. And there's a limited number of services that you can use and characteristics, but you probably won't overload it. But you want to do your service, and then you want to do your characteristics related to that service, and then go to the next service, and then do those characteristics, all the while memorizing the index numbers of the services and the characteristics so you can reference them later when you're trying to do some stuff. So with the characteristics, they actually have some properties that you want to know about. So there's some things that you allow read, write only, read only, right? What do you want it to do? You can give it a default value, right? So all these things I kind of set up in here. And again, if you just look over here at the data sheet and you look up these commands, if you look up this command right here, you'll see what it is you have to send. So when we're writing a characteristic, we want to pay attention to the properties that we can write. So we can see here that I've got this one as a read-write characteristic, which means that this is a peripheral. So the peripheral is going to have data that it wants to share with the central. Well, the central also may want to modify that data. So how do these things work? Well, for a character read-write, for car read, car write, that means that the peripheral is giving the central permission to do that, right? So if you only wanted it to be a read value and not the central, and not allow the central to write to it, then you would just have car read, right? If you want to have it something where they can't read that value, but they can write to it, then it'd be just car write. But if you want the central to be able to both read and write to that value, then you're going to have both read and write. Now the central has the authority to be able to read to that value, to that characteristic, and write to that characteristic. So the central can change that value. The next one is my notify one. This is to notify the central that something is happening. So this one up here, if notify isn't activated, then if the peripheral changes that value, the central will not know. The only way the central will know is if it actually does a physical read to that value to see if it has changed. But the notification one, this is one that says, hey, I changed something on my side. The peripheral says, I changed something on my side, and it then notifies the central, I have a change in value, right? So it lets the central know that, hey, something happened, you need to come check it out. And so those are what the characteristics here are doing. And then I go ahead and fill up some manufacturing data, just dummy data, to throw it out into the air. And then once I set up my services, my characteristics, and everything else, I got to then reset the device in order to have everything activate. I give a little delay, wait for the thing to boot back up, just waiting for and it takes a while for the NRF chip to boot back up and reestablish itself, and then go ahead and complete. So my setup is pretty easy. All I do is reset the device, factory reset the device, initialize it, add my services and characteristics, reset the device, and now I'm ready to do stuff. So now that I want to do stuff, what is it that I want to do? Well, I'm going to take that characteristic, that int32. Remember I said that you got to remember the index for the characteristics? It's because if I want to see those characteristics, I need to reference those characteristics. And so I'm going to look at that characteristic. I am going to say, I want to see this one, and what is that number? If that number happens to be a 24 or a 25, then just go ahead and do these things, right? What are those things? Well, it's going to be, let me toggle the relay, whatever it was, flip it the other way. And then I want to go ahead and write out to that same index. I want to write out the number 42 to it. So I'm going to write it. And then I'm going to go ahead and modify my notification status. So am I in the energized state or am I in the unenergized state? That's what that's asking for. It's like, hey, is this high? If it's high, meaning energized, I want to go ahead and put notify status at 2. And if I'm de-energized, if I'm low, go ahead and make my notify status FD. And then go ahead and write that characteristic to my notify. So what's happening is I push the button. That button then goes and writes to the RW32 index characteristic, and it writes a number, right? 24, 25, depending on what button I press. And then after I receive that button press, I then modify and I toggle the relay that was requested, and then I notify the notify characteristic. I modify that to let the central know, to let the remote know that, hey, I got your message, I changed it, and now here's the new value of what that relay was. So that right there is pretty much the entire program. I left the switch thing in there from the original setup, so I can still push the button and flip the relay. But other than that, I just wait 5 milliseconds and then loop through the whole thing again so that I can just keep looking. And all I'm really doing is I am looking for them to modify this number. So that's the peripheral side. That was the Arduino with the relays. The next episode we will go through, we will actually show the remote side. That was the ESP32. We're going to still be in the Arduino world. The ESP32 still uses Arduino, but on that one will be the central instead of the peripheral. So our code will not be making the advertisements and services, but the central will actually look for the advertisement, connect to it, and then read and write and respond to the notification process. I will see you on the next episode where we'll go over the central side and see how it is that we can control this relay with the remote. Thanks so much for watching.